Good evening, everybody, and welcome to another evening of the AWS Portsmouth User Group. Tonight, we're very excited to talk about something that has recently been near and dear to my heart. It's hard to pronounce. It sounds a little funny. It's called Kubernetes. Some people use the letter 8 and just stuff that in there between the K and the S and get it over with, or call it Kates. And tonight, we're going to learn about Kubernetes, we're going to learn about orchestration, we're going to learn about containers, and we've got somebody very special here to help show us all of this stuff and do a little bit of a demo at the end. Tonight we've got Eddie Zaneski. Did I say that right? Is it Zaneski? Or okay, awesome, fantastic. I'm 3 for 3 on pronouncing names properly today. Good deal. So first, before we get started, a couple of housekeeping notes. If you want to get in on the conversation, please feel free to either at AWS Pug on Twitter to us. Me and Chris are both watching the Twitter feed, so we can answer questions either through there. Or if you're in the live studio audience tonight, you can feel free to unmute. Please be polite when you do that, though. Or talk in the chat channel. Ask us questions in there, and we'll make sure that we get all of your container orchestration, Kubernetes, Kates questions answered. And of course, the big question that was on top of everybody's mind, what is Chris Planke's facial hair status today? Today, he is clean shaven. So we were very excited to see him going back to his clean cut looks. Also, here is Eddie Zane on Twitter. If you please feel free to follow him. And yeah, let's go ahead and light this candle. I'm gonna stop share. Eddie, are you ready to go?
Yep.
Awesome. The power is yours, sir.
Awesome. I'm stoked to be here. Thanks for having me, all of the Chris's. I see 3 Chris's on my screen right now.
So many Chris's. It's ridiculous.
Thank you all for having me. So I'm Eddie Zaneski. I'm a developer advocate at Amazon Web Services. I am based out of Denver, Colorado. Originally from New York. I moved here about 2 years ago. Let me share this. Okay, can we see that?
Yes, we can see your screen.
Cool. So quick bit about me. Like I said, I'm based out in Denver, Colorado, but when there's not a pandemic going on, I'm usually traveling, and I'd probably be joining you all in person, but fortunately we're stuck to our keyboards and computer screens today. I'm a Kubernetes contributor and a Kubernetes organization member. So I work on, if you're not familiar with the Kubernetes project, it's broken up into different kind of like steering teams called special interest groups. And so the special interest group that works on kubectl, which is the command line tool to talk to Kubernetes, which we'll take a look at in a bit, is called SIG-CLI. And so that's what I've been working on mostly. So I work with SIG-CLI to help make kube control better and to hopefully not get you all mad at us. So feel free to send angry comments my way at some point. Before we get started, I'd love to get a gauge of everyone. So if y'all could open that chat. And on a scale of 1 to 5, could you drop 5 being you are a super expert and 1 being you are just beginning your journey? If you could drop in a 1 to 5 on where you stand with Kubernetes in general. Okay, that's awesome. Y'all are in for a treat. You got a long road ahead, but it's a fun road. Cool, a couple twos. All right, and what about containers? How about Docker or containers in general? Okay, a couple of people more familiar with some containers. All right, so we got some 3s, some 4s, couple 1s and 2s. Say it averaged about a 3. Cool. Okay, so that's good. So we'll touch containers briefly, but we won't focus on it too much. And like Chris said, Kubernetes is pronounced many different ways. I've heard Kubernetes, that's my personal favorite. Kubernetes. When I was out at KubeCon in Copenhagen with a really thick European accent, Eastern European accent, someone called it Kubernetes. He said he's a Kubernetes developer, and that was the best thing in the world. I was very happy to hear that. So our agenda for today is we're going to take a quick talk about what a container is. Then we're going to go over what Kubernetes is in general, and we're going to look at Amazon EKS, which is Amazon's Elastic Kubernetes service. And finally, we'll dump into my favorite part, which is a bunch of codes and demos. So feel free to drop those questions in the chat if they come up. I'll keep an eye there, or feel free to pop on the mic. And I'd love for this to be a discussion. Before we get started, one more thing. Is there anything particular you're looking to learn about Kubernetes or containers in general, so that I can keep that in mind as we go through? Maybe you're curious about user control or security policies. So if there's anything like that that you'd love to know a little more about, feel free to drop that in. And so I like to start with a definition of what a container is, right? And so taking a step back, back in the day, we had binaries for everything, right? Before the internet and the cloud was a thing, we had compiled C binaries that we tossed around. That was pretty great. Generally, if it was a statically compiled binary, it had everything you needed to run the program. Wouldn't use much dynamically linked libraries and such. So it was a pretty portable binary. You could compile it for an architecture, ship it around. It was pretty great. And then we start getting into more scripting and JavaScript and PHP. And so now we actually need servers that are running. And so for you to deploy your application, let's say you have a PHP application, for you to deploy your PHP application to a server, you need to make sure PHP is installed. You need to make sure a web server is installed, right? So there's a whole bunch of dependencies that are required beyond your code to get that to work. And so a container is the idea of taking all of those individual dependencies, packing them up into a small, tiny package, and we can ship that off, and it basically runs on my machine like it would run on your machine. So I like to refer to it as a cloud binary. Some people probably cringe and roll their eyes when I say that, but I think at the end of the day, a container is a cloud binary that can run agnostic of generally where it is. So my favorite definition for a formal definition is this definition from Docker, which is a very popular container runtime. And it says, a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. And so I think the important part in there is packages up all its dependencies, right? Because it's easy for us to ship our code generally, but for us to take all those individual dependencies that our library and our software depends on is super critical. And that's generally where you have the issues with doing deploys in the first place. And so I like to look at this evolution. So this is from the Kubernetes website. Some pretty great docs there if you want to check this out. And so jumping back again, we had, our traditional deployment where we actually had rack and stack hardware. This is before the cloud days. So you'd have actual server hardware. You'd install an operating system on that, and you would have your, multiple apps, maybe one app per server running on it. But this is where you'd have to call someone up in the data center or to go out there yourself and actually slot in your hardware and get it plugged in. And then we actually entered the area of like virtualization. So this is where cloud providers came in. If you're not familiar with what a hypervisor is, it's basically a layer that runs on top of the operating system right above your virtual machine. And it kind of acts as the orchestrator to provision out individual VMs on there. And so you can see that we have individual virtual machines. And the downside here is that each of these virtual machines has their own operating system, right? So they have their own full copy of Ubuntu or Windows or whatever operating system you're using. Each of these VMs has their own full copy, and included with all those libraries and binaries we talked about, plus your application, right? So there's a lot of overhead here and there's a lot of duplication. And so with the container deployment, we swap out that hypervisor for a container runtime. There's many different flavors. I mentioned Docker is the most popular one. And so what that container runtime lets us do is it actually lets us mount in the host's operating system into our running containers via a copy on write type file, right? So it's basically using all of the host operating system kernel and files until one gets modified or tweaked a bit, and then it'll copy that file, make its own copy, and kind of control that locally. But until any of that write is done, it's basically not duplicating any OS. So we save, generally our containers are as small as possible to get this going, right? So we can, I'm a Go developer, so I can compile it down, a Go container to be like 6 megabytes or something, right? Because it can use the host operating system. And so that's what's really unique about these containers, is it saves on efficiency. It allows us to actually bin pack, where we can take all of those containers or those apps that were originally running on servers and slot them in Tetris and efficient style onto a server where it gets carved up as resources. And we'll take a little more talk about how we carve those resources up. But this is a good thing to understand, is how we've come to this container deployment phase. And so with that, Kubernetes obviously comes up. And so Kubernetes is a container orchestration system, which originally started as an open source project out of Google. It's based on Google's internal container platform called Borg. It's been through a couple iterations. I like to call this the heart of the cloud native movement. If you haven't heard the term cloud native before, it's this idea where we're designing software to run in the cloud natively. So instead of taking our stuff and lifting and shifting, we're actually building software that is originally designed for the cloud. This has its own set of problems, but it solves a lot of the old ones. And this is software that's designed to run everywhere from on-prem to the cloud. Kubernetes affords you automatic scaling and self-healing, which is a great feature. We're going to take a look at that later on. And innovative declarative resource model. And most people will never write their own controller, which is exactly what it sounds like. It's a controller inside of Kubernetes that does its own lifecycle things. But Kubernetes actually is very innovative in how it came up with the data resource model. So when you create a resource in Kubernetes, everything is API driven. And so every single resource is backed by an API. And so you call it to the Kubernetes API, you say, hey, create me this resource. It writes out to a database. Database is usually etcd. It's just kind of like a key value store almost. And so we write out to etcd and we say, hey, this resource should exist. Those controllers are kind of running in a loop and they see a resource that should exist that does not currently exist, and then it goes out and creates it. And it sounds like a very simple model, but when you scale this out to thousands and thousands and thousands of nodes and pods, it's like super efficient. So if you ever get a chance to dive into how the resource is modeled under the hood, it's really cool. Here's the architecture of a Kubernetes cluster. On the left here, we have what's called the Kubernetes control plane. This generally runs on a single node. If you're using a managed service, this control plane node is generally completely obfuscated from you. So you generally don't even get access to it. So a cloud provider will manage this for you. They'll scale it. They'll keep it up to date, keep backups and replicas. And so you generally never have to worry about this control plane. And all you generally worry about are the worker nodes, or the nodes that are on the right here. And these are your individual EC2 servers or your worker nodes, whatever you're using. And these run what's called a kubelet. So it's pretty much just a Kubernetes daemon on there and a Kubernetes proxy that lets it do the network translation between all the nodes. And that's pretty much all the nodes have. Is there, you can take a huge beefy server, fire up this tiny little kubelet, enroll it in the cluster, and then it can be provisioned resources. And one of the most powerful things here is, I mentioned, we no longer have to think about our compute resources as individual servers. What's nice about our worker nodes is all those resources can get added together into a giant pool in the cloud. And so we wind up with I have maybe 4 EC2 instances that have 4 CPUs and 20 gigs of RAM or whatever. And so I don't care how many nodes I actually have. At the end of the day, if I have 3 of those, I have 18 CPU nodes. And that's all I care about is Kubernetes will divide up my resources and my apps that need to run intelligently. And whenever I need to scale, I just add more worker nodes. It's super easy to enroll more. Couple other bits on here. This cloud controller manager is pretty important. So this is what lets cloud providers plug in and substitute their own features. So someone asked in the chat about persistent storage, so we can talk about that a bit later. But this is so when you ask Kubernetes for some kind of disk or storage, the cloud controller manager, along with the cloud storage interface, container storage interface, the CSI, sorry, it can provision you out EBS volumes if you'd like and attach them to those worker nodes. So there's a lot of moving pieces here, but this is a general architecture. We have a control plane and individual worker nodes. So again, if you have questions, feel free to drop them in. I'm moving a little quick. So jumping it back to the resources, the basic unit of Kubernetes is what we call a pod. It generally represents a container. Pods can technically have more than one container running in them, there's very few situations where you actually want to do this. So it's easier to just always equate one pod to one container. If you take a look at the right here, this is a Kubernetes resource definition. This is the YAML syntax if you're not familiar with it. It's basically key value pairs. You could convert this to JSON pretty easily. And so every single resource in Kubernetes has 4 primary keys. We have an API version. So this just declares what version the resource is, what kind of version this is, or what type. So in our case, we have a pod. Metadata contains a bunch of arbitrary values. Some are important, some are just things you can tack on. So here we have the name value. So this is the Nginx pod. And then we have some labels. Labels are key value pairs that you can kind of target and select on. They're basically like AWS tags that you can have in your resources. And so you can select on those, filter on those. And then we have the spec. This is the specification. So this is really where the meat of that resource is. And so here you can see this pod has a spec where it has a containers value, and it's an array. So if you're not familiar with YAML, that little dash denotes the start of an array or a list. And so we have a single container in here named Nginx. There's the image, and then we have the ports that we want this container to map around. So container port 80, protocol TCP. Again, you generally don't want to create pods yourself. We have higher level resources that we work with. So you don't really want to create pods manually. You want to let something else that we'll take a look at next handle it. But this is really where it gets either scary or easy for a lot of folks. You're being very declarative with how you're declaring these resources, right? So you're saying, hey, this is what a pod should look like, whether you're using CloudFormation or Terraform code. It's the same kind of thing. And so you actually take this YAML manifest and you apply it to your Kubernetes cluster, basically through an API request, and it goes out and creates you a pod. Any questions on that one? I know that's a lot. How many does it make sense? That is a great question that is very hard to answer. A lot of people will say most folks don't need Kubernetes. They're probably right. That said, if you're starting from cloud native, using Kubernetes, it can make a lot of things easy. You kind of get universal logging, you get automatic scaling. So we'll take a look at some of the features towards the end, but yeah, that's it solves a lot of problems and introduces a lot more. Even containers for that matter. So that's something, so there's different things we can tack in. There's, we call them like pod autoscalers. So you can have auto-scaling groups based on metrics. So maybe the CPU or the response time for your individual pod or container is taking too long. Kubernetes can automatically increase that pod count. So we'll take a look at that as well. So deployment is really the unit that you're going to work with. Again, you don't want to create pods yourself. You want something else to create them for you. So a deployment represents a single app or service. This is the most common resource you'll use. It's completely isolated from other deployments by default. And if you take a look here, we have some of those same values. So API version, kind, deployment, some labels. Then we have our spec. And here I have replica set to 3. So this deployment is going to have 3 instances of that container running that's down below. And if you notice, we have a template field, so spec.template. This is a syntax you'll see pretty often when we're referring to Kubernetes manifests. It's just saying go to the spec key and then drop down into the template key. And so spec.template is actually the pod spec that we had here. And that's really powerful and cool when you're looking at the documentation, because again, all of this is API resources backed by Swagger or Open API, whatever we call it now. But the API definition, it lets us represent these resources. And so when you're doing docs and trying to figure out what values you need to plug in, it's super easy because this spec.template will actually just point you back to the pod spec. Couple other bits in here. We have a selector with some match labels directive. So this is going to match the labels app Nginx, which we also have down in the template there. Labels are one of the things that confused me the most when coming into Kubernetes, mainly because you see them duplicated everywhere. If you look now, you see how many copies of app Nginx? I think 3. And so it doesn't, there's conventions for labels. There's some actually like standard labels that no one really follows from the Kubernetes docs. All that matters is you keep consistency across. name, namespace, and labels are all unique to resources. So you can have the same labels on a resource as long as it's in a different namespace, or as long as it's a different type of resource. And so pretty much this just matches and selects all these Nginx pods that get created that are matched with app Nginx. Again, it's kind of confusing until you get the hang of it, but this is what tripped me up the most when I was getting started. Finally, we have a service. And so again, I mentioned our deployment is completely isolated, right? So nothing inside Kubernetes can talk to each other. Everything's locked down by default. So it's basically a deny all IP rules. And so what a service lets us do is it lets us create a resource that lets deployments and other services talk to each other and also expose it to the public internet. And so there's 3 different types of services. Cluster IP, that's if you just want your service accessible internally inside your cluster to other services. Kubernetes runs its own DNS server. And so it's actually really nice because when you go to query something, you don't have to, do any service discovery. You just say you want your, there's like a hierarchy where you can walk up. So you can say, give me nginx.local.this namespace or whatever. But the service discovery automatically happens. And if you're not familiar with the term service discovery, it's pretty much just how you plug and connect your resources together without hard coding IPs or DNS names. And so a node port is kind of the next step up. So this is how we expose our deployments to the outside world, or one of the ways. And so this will generate us an arbitrary port greater than 30,000 or something. And so then you can take any of the IP addresses for your worker nodes, tack on the node port that gets randomly generated, and you get a publicly accessible version of your deployment. That's not really useful though, because we can't really map DNS to a port. And so that's where load balancers come in as the service type. And this is where that cloud controller manager I mentioned gets to do its magic. So when you create a service of type load balancer inside of EKS, Amazon can spin you up a network load balancer or an application load balancer or a classic EL, whatever you want to use. It can spin one up for you. So you have a unique generated individual endpoint that you can hit and map your own DNS to, generate SSL certs for. So those are the 3 basic units you'll be working with. I know it's a little confusing, so again, feel free to drop those questions in if you have any. But one of the important things to note here with the port mapping is so this goes for Docker and containers as well. Whenever you see the kind of the ports that are mapped, port, or generally the first one, always refers to your container. So it's usually source to destination. So this is saying, hey, map my port 80 to my container port 80. And so we'll take a look at that a little later on, but that's what the 2 individual ports will mean. So you have a port, the first port maps to your source, second port always maps to your destination. Next is Amazon EKS. So this is Amazon shot at Elastic Kubernetes service. Our customers wanted us to create a managed Kubernetes service because managing Kubernetes is hard, just like managing a database. Everything about Kubernetes is hard, but managing a cluster is very hard. Specifically deploying a cluster. And just like managed databases, right? You generally want to use a managed database as opposed to managing your own database. You definitely want to use your own managed Kubernetes cluster when you can. There's Kelsey Hightower is a pretty awesome developer advocate for the for Google and Kubernetes. And he has a great open source project called Kubernetes the Hard Way, where you go through and deploy a Kubernetes cluster manually. So if you ever want to peel back the curtains and see what's behind it, it's a great resource to check out, but definitely steer clear when you're first getting started. So EKS is a fully managed Kubernetes service. It deeply integrates with services such as CloudWatch, auto-scaling groups, IAM, virtual private cloud, and it runs upstream Kubernetes and is certified Kubernetes conformant. And so basically what that means is we take the open source version of Kubernetes, we tack on the few little bits that we need to make it run in AWS, and you get a almost vanilla Kubernetes experience. And that's what's really nice is you can take your workload to any Kubernetes cluster and it should work in theory. Whether you deploy one yourself using a managed service, there's Kubernetes conformance testing, which is pretty much just automated testing that runs, and your Kubernetes implementation can pass the conformance testing and you are certified, right? So EKS Kubernetes should be the same as any other place that's running Kubernetes. A couple of our awesome customers that are using it, Intel, Snap, Intuit, GoDaddy, Fidelity, Autodesk. There's a lot more. The AWS definitely became one of the early folks to become a hotspot for running Kubernetes workloads. I think the CNCF survey the CNCF is the Cloud Native Compute Foundation. I don't want to misquote it, but I think it was something like 60 to 80% of all container workloads run on AWS hardware. So that's a pretty cool stat. Looking at EKS a little bit. So you can create an EKS cluster. You're given two profiles to have your worker nodes be. So you can either use AWS Fargate. So if you're familiar with ECS or Elastic Container Service, it's pretty much abstracts away the concept of a server for you. It just, I don't know, I probably relate it closer to Lambda, where you don't have to think about individual Lambda servers, where you can just run your resources and not worry about managing infrastructure. And then if you want a little more control, you can deploy your own EC2 nodes through EKS, and EKS will manage those for you, right? So you're kind of given a choice if you want to use Fargate, which is a pretty nice way to get started if you're not familiar, or EC2 if you want full power, full Kubernetes experience. So those are the two options you're given. And so now we get to jump into my favorite part, which is the demos and codes. And so I have a EC2 instance here. I mean, a EKS instance. And so if I want to create a cluster, I can come into my AWS console, I can sign up, do all that fun stuff, and I can go create a cluster. I can fill in all these versions and values with some names. But then the next page is where it gets a little confusing, where I have to pick some subnets and a bunch of other stuff. And unless you're really familiar and experienced with this, we actually recommend using a command line tool to create these clusters when you're getting started. The defaults are very same. And so that's actually EKSCTL. And so EKSCTL is built by one of our partners called Weaveworks. They're the ones who pioneered GitOps and a bunch of other cool stuff out there. So this is an open source project that we put a bunch of resources into. So this is how we recommend you all go and create your clusters. So you just download EKSCTL and you can do create cluster. And I think you can give it like a node version.
Real quick, Eddie.
Yeah.
For those playing at home and want to follow along and type along with you, do you have this in a repo so that they can see what you're doing and emulate it, or?
I do not, but you can just download EKSCTL as long as you have the AWS CLI created, and the command that you're going to run is just going to be EKSCTL create cluster. You don't have to pass it any flags. It'll create you a pretty sane two or three node cluster out of the box.
Okay, cool.
This will take a bit to run. So I've already baked one in the oven, so to speak, from my cooking show paradigm. But feel free to give this a run if you'd like. But again, it probably won't finish until we're done with the session. So
Gotcha.
It takes a little bit to get
Thanks.
spun up. Basically, actually, what this does behind the hood is kind of cool. Kind of like everything inside AWS, this creates a bunch of CloudFormation YAML and shoots it off and gets built and all that jazz. So at the end of the day, you're always working with the YAML. So you can't escape YAML. So I've got a cluster created already. And so the primary way that we interact with Kubernetes is through the command line tool I mentioned called kubectl. This is also pronounced very different ways. kubectl, kubecontrol. Technically, the right answer is kubectl because the mascot is a cuttlefish, but I always say kubectl. And so the hello world, excuse me, is kubectl get nodes. This will go out. So you see here, I have a 3-node cluster. It is running version 1.17, which is the latest available inside of AWS. 1.18 is a little bleeding edge still, and 1.19 was just cut for a release branch. So Kubernetes moves really quick. We cut a release every 3 months or so. And so kubectl get nodes, this is the hello world. So this gives me my worker nodes that are currently running. I can throw a couple different flags on here. So -O is for output. So -O wide is another one you'll see. So this kind of gives me those external IP addresses of those worker nodes, the kernel version that's running. Amazon Linux 2 is the OS, a bunch of other fun jazz. I can also get that in JSON if I want. Maybe you want to parse this for some sadistic reason, or maybe you want a full YAML output of all this. You can do all those things. So almost every resource in Kubernetes you can change the output of, which makes it great for scripting. So feel free to poke around with that. So I have I shouldn't have any deployments created here. So again, remember those deployments we mentioned. So I can say kubectl create deployment. I can give it an image. So we'll say nginx, which is a web server if you're not familiar. I think it's 1.14.2 is the tag. So in the container world, you'll see containers labeled very different ways. Generally, we have the name of a container. So in this case, it's nginx, and then some arbitrary tag. This can be a git commit hash. This can be a date, or in this case, it's a version. So this is version 1.14.2 of nginx. And then I can say, create me that deployment, and then I have to give it a name. So I'm just going to name this deployment nginx. So that'll go out. It'll write it to that database I mentioned, and it'll go create it. And probably by the time that I get those deployments again, I will have my app deployed and ready. So what this did is it pulled the nginx Docker image from the Docker Hub, created a pod, so I can get those. So I have a kubectl alias to k, so it's just so I don't have to type kubectl every time. So if you see me type k, that's all that is. And so I can say k get pods, and I have one nginx pod that got created. You can see here that it's just tacked on some arbitrary identifier. You know, it's 28 seconds old. And so if we take a look at all the resources, see how we're doing on time. Okay. And so we see I have that pod that was created. Ignore this service. This is just the Kubernetes cluster service. It's so everything can talk to each other. And so I have that deployment, right? I only have one replica right now. It's up to date and available. And you also see this replica set. So I mentioned there's a lot of hierarchy in these Kubernetes resources. So replica set, so deployment creates a replica set. Replica set what's actually responsible for making sure that there are the desired number running, right? So you can see that there's desired 1 and 1 is running. If for some reason, let's do a little watch. So this is just gonna constantly hit that command. So keep your eye up here. If for some reason that pod dies, so I'm just gonna delete it, you'll see that the pod is getting terminated, it got deleted, and the replica controller was like, oh, there's supposed to be 1 running and 1's being deleted. So that means I need to create 1 more, right? So it just kind of created me another one, and it takes care of all that for me. So I don't really have to think about it. I can grab the logs of this if I want. So kubectl provides a way to get logs. You can also log through CloudWatch or any other logging tool you want. There's a whole world of open source logging and monitoring tools in the Kubernetes space. So if you ever have a bored Saturday, feel free to look at all those. But CloudWatch works really well. And so I can get so I can say logs for that pod. And there's actually no logs right now. There's nothing sitting it, right? But there would be logs if it had traffic. So cool, so we have a deployment. We can't really access it. So let's expose this as a service. So the command to do that right now is expose deployment nginx. And I'm gonna call this nginx. Ooh, there's something wrong. Oh, I gotta give it a port. So we have to tell it the port we want, which is gonna be 80 because it's a web server. And so it's exposed. And we should see a service pop up over here. There we go, the nginx service. It's given my deployment a cluster IP, right? So this is accessible inside of my cluster. I don't actually have to worry about the cluster IP. I can just talk to nginx as a DNS name whenever I want, and it'll magically route it to me. But it's still not publicly accessible. And I should have mentioned early on, these commands here, they're fun to poke around and play with as a lab or while you're learning. You generally don't ever want to run these commands. You want to write your own YAML manifests. So for example, take a look at this deployment that we created, you can see, you don't have to write a lot of this, right? A lot of this is populated, but you want to write your own deployment manifest. And that's just so everything's repeatable, right? You don't want to go into your cluster and manually muck around and change things. But you can, a nice way to get started with this is to actually create one here, and you can just save this out to a file and see what kind of fields you're supposed to be looking at. So there's that spec we mentioned, there's that image, there's different pull policies. All right, so it's YAML, it's confusing, there's a lot of it. But as you start doing this a bit more, you'll kind of learn the conventions. Yeah, so anyway, so we need to tweak our service a little bit. And so this is actually one of my favorite commands, is the edit command. Again, even though you shouldn't do this in a real world scenario, we can edit that service live. So it's actually going to go out, grab that full resource, open it in my text editor, which is just Vim here. And then I can come in and make little changes. So I can say, oh, I want this now to be a node port. And I save that. It's actually going to go and it will upload the file that I changed. You can have it open in Atom or VS Code or whatever you're using. And so now it's actually exposed that as a node port. So I can go grab that IP address of the server, toss on that node port, and we should get our deployment. But what I actually want is, in this case, I want a load balancer. So I'm going to say, please give me a load balancer. And we should see pending here. So that actually happened way quicker than last time. And so it's already spun me up in this case, I think it's just using a classic ELB because I didn't specify anything. So here it spun me up a load balancer, wired everything up, got me a DNS name that I can mess around with. It should not take too long. Let's see. If we pull up our load balancers.
To help you fill that time, can I ask a question about
Please.
how do these, so I see all that you created a load balancer here, and that's the AWS load balancer that I'm really familiar with, something that I would define via infrastructure as code or something along those lines. Earlier on in the presentation, you showed there was like nodes, load balancers, and I think one other part of the Kubernetes definitions. How would a load balancer that you defined there map to one of these load balancers without that tool that you were just demoing?
Right. So let me make sure I understand. So if we look at the load balancer, it actually has those selectors in here. And so these selectors, this is where it gets really confusing. This selector matches the deployments labels.
Okay. And so in your CFT, when you define like a load balancer, there would be some sort of linking between those two, or yeah, okay. Correct.
Yeah, so if we look at that Nginx service, you'll see it'll actually pop in a selector for me. So it's popped in, the create command kind of just arbitrarily, tacks labels on for you. And so this selector, that's a great question. So this selector matches the deployments labels. So if we edit and you also don't have to edit, you can just get instead, which you probably should do. Right, so this actually tacked on those labels automatically when we created it. Gotcha. But again, inside your org, you decide on your own rules for labels. Again, they're completely arbitrary. There's some like recommended ones from the Kubernetes project, but you can arbitrarily come up with whatever key value. They're tags, right? At the end of the day, they're tags. So. Question in chat, is there a way to disable edit? There is. I don't think you can disable the edit I showed you. You can disable the write functionality. If we have time at the end, I'll show you what we call RBAC. It's role-based access control. It's basically IAM inside of Kubernetes. So you can disable writes to a resource or a user, a role, or a group. But I actually don't think you can restrict the edit command. That's a good question. I should find that one out. Okay, so our load balancer should be good. Let's take a look. So we have an Nginx, hooray. And so let's do that get again. So let's watch. Get
this app's already more responsive than the Meetup website. Congratulations.
Oh gosh.
Shots fired.
All right.
Nice.
Shots fired. So there's different ways to scale. I'm just going to use the scale command. This one, it's not that bad for you to run from the command line. You can always tweak this one. So I'm going to scale the deployment to, let's say we want 50 replicas named Nginx, right? That's the deployment's name. So just like that, it's going to go out. It's going to download a bunch of containers for me, and it's going to spin them up and schedule them and place them on worker nodes. Again, you can automate all this based on metrics. There's tons of rules and filters you can write for the pod autoscalers and horizontal autoscaling. And but yeah, so when our traffic surge is done, when meetup.com comes back, we can scale back down to 5. It'll clean that back up. And this is what most people are like, oh, this is nice. Yeah, this is great. It's super powerful. Gives you a lot of other issues. Again, solves problems, creates more. Some other cool things we can do is we can set the image. So we can set the image for the deployment named Nginx to something. I don't remember the exact syntax. But if we wanted to do a deployment, right? So let's say we have a new version of our container, right? Our CI/CD built it. And the question in the chat about pipelining all this is awesome, right? It's the same thing. So this could be all pipelined by our CI/CD, and it can just use the Kubernetes kubectl tool here to do a deployment, right? So it can do kubectl scale deploy, set image deployment, and just pop in the new git commit hash or the new tag of your container. Kubernetes has different deployment strategies, so it can do rolling deployments. You can do surging. You can say like, oh, only update one at a time, like update one and bring it back down. Tons of options, tons of power. It gets confusing again. Cool. So there's one last thing I want to show. How are we doing on time?
Oh, we're doing fine.
Okay. So we have our load balancer. It's kind of, this is an automatically generated URL. This doesn't help me very much. It's ugly. I can't really wire up SSL on it easily. And so there's a bunch of open source projects and tools that make wiring this up really easy. Cert Manager is my favorite, actually. So definitely take a look at Cert Manager. This actually issues you Let's Encrypt certs, and it can actually write to Route 53 DNS for you. And basically it just magically works, right? You can create a deployment. Cert Manager can create you a cert, set up all the DNS inside of Route 53, tack it onto the DNS for the load balancer, and boom, you have an automated deployment. People like to do complete. So one of my favorite things I've seen is people deploy pull requests to Kubernetes. You can have namespaces, right? So they're kind of completely isolated, just namespaces. So you can deploy a pull request to a namespace, generate a completely new SSL cert, generate a completely random DNS name, have a bot comment it back on your pull request on GitHub, so your reviewer can actually go in and check it out, right? It's like a live, completely isolated PR deploy. Really cool stuff. So Cert Manager is a great tool to use. Definitely check that out. Where is I going? Oh, another bit. So you'll see ingresses mentioned a bit. So ingress controllers. So you can use an ALB for an ingress controller. There's a whole bunch of them. This is basically, so every time you create a service with a type load balancer, it will create you a load balancer. Maybe you want that. Maybe you want an individual load balancer for every service. That can get expensive though, right? Especially if you don't have a lot of traffic, just to get a publicly accessible URL. And so what most people do is they create what we call an ingress controller. So in this case, the Nginx ingress controller is exactly what it sounds like. It basically creates an Nginx instance and it gets wired up. I think there's a doc in here that looks good. This one. All right, so this will, so you basically deploy it with a kubectl deploy manifest, right? So we can deploy from a URL or a local file. Where's what I'm looking for? AWS. There's a good example in here somewhere. But anyway, it's just a YAML manifest, and it's just a resource like every other thing, right? And so the Kubernetes ingress controller for Nginx will go, it will slurp up your ingress, it'll actually write the rules into the Nginx config and magically manage all of that for you. So again, the way we save money, maybe if you don't need a load balancer for every single application, is you can use one ingress controller and have it route and be kind of like your actual front-end load balancer into your cluster. And it can work with every single service or deployment you want. Okay, back to what I was showing. So I have a cert that's deployed. So I have this awesome vanity domain called kubernetes.dev. You get it? It was a great one, right? The coworker thought of that.
Kudos.
Coworker thought of that one. And so I just have the ARN for that, that resource here. And so if I come back in, and so I can edit that service again. And so this is where things get a little bit not cross-compatible, right? We talked about conformance testing. It is actually really hard for cloud providers to provide the same experience because AWS has 3 different types of load balancers right now, right? Like that's when you ask for a load balancer, which one do you want? By default, it's the classic ELB. So we have this thing called annotations that lives in the metadata field. Again, just like labels, it's arbitrary key value pairs. But in this case, they actually do something. And so I have an annotation here. So I just added this annotations block, annotations. And there's some docs here. Where's that? I closed all my tabs by accident, which is why I'm fumbling right here. Here we go. So this is the cloud providers docs inside Kubernetes. So you can see all the bits and pieces. So I'll blow this up a bunch. And so here's all those annotations that you can specify. You can specify the log level that's emitted, what S3 bucket to use to log into. So these are just, this is kind of like the AWS secret sauce that we can tweak. So when you see annotations, that's generally what we're doing is you kind of just toss these arbitrary strings on there and the controller will go out and find them and do what it needs to. And so I'm gonna grab this one. So this is just the AWS Load Balancer SSL cert tag. So I pasted in that ARN for the cert I created. If I save this, it's automatically gonna go in there, map my my SSL cert to my ELB. It'll wire up all of the listeners for me, take care of everything. The only thing we actually have to do is we have to switch this from port 80 to 443 so we can talk to HTTPS. So again, just the same file I just edited. So I'm just mapping that now to 443 instead of 80. And then I can come back and I can go into Route 53. And go in here. And again, there's tools that automate all this and you can do it all very quickly and easily. And so I'm gonna create a new record. Let's just call this Nginx. I'm gonna alias this to my, what is the 845. I got Zoom in the way, create that. Boom, right? So I created a record. Now if I hit the nginx.kubernetes.dev, I should get the TLS cert automatically mapped on there, right? So now I have a secure encryption. Again, you can do all this from inside of your cluster. It's kind of just easier to demo this way. But you can map all these things together and they all play really nicely. So I know that's a lot. That's the majority of what I had to demo. Does anyone have any specific questions? Someone asked about storage. So inside of storage, we have different storage options. So we call these persistent volume claims or PVCs or PVs for persistent volumes. So I can create a persistent volume. What do I need to specify? Create persist. Okay, I guess I can't create it this way. But you can create it the same way. So you create a persistent volume inside of your deployment. You can map a volume directly in. One of the awesome tools in here is, so you have a describe command. This is kind of, so let's say we want to describe the deployment. So this kind of gives you a bit more information. You can see kind of the events that happen. So you can see those scalings I did. Has a couple of other bits. The best thing that you're going to be playing with outside of the docs when you get started is going to be explain. So you do kubectl, explain. Let's just say you want to explain deployment. And so this will go through, it'll hit, so every single, inside the API server, the Kubernetes control plane, it's running a open API endpoint or listen or whatever. So this will go out and actually hit that API, pull back the complete API specification, and let you play around and poke it here, which is cool. So I explain what a deployment is, and see I got these definitions. And so I got, okay, I don't know what a spec is. It's an object. Okay, that's cool. So then I can say, hey, give me that deployment.spec. And there's all the fields that I can specify, right? There's that replicas I showed you before. The selector, right? It marks which ones are required. So this is like really powerful and really great to get started with. Last thing I'll show is, you see we have the template here. So we can grab the template. And like I mentioned, this actually will just be a pod template. So if we look at the spec here, it'll actually point us directly to the pod spec. Right, and so I scroll up. This is the specification for the pod, right? And so this is actually the object that represents the pod. That's the first resource I showed, right? So all these things play together nicely. It's really nice that they're all objects because you can use them and reference them every single place. So, okay, what do we got here? Questions?
Oh, so you said that you were getting ready to wrap up. So I was putting the link in the meeting thing to make sure that everybody got online and did the survey, because once you've finished, then we get to do the giveaway, which we're all very excited about, of course.
So everyone at home, go to awspug.org/survey.
Yeah, and you can't put it in because we're all talking about you behind your back right now, how you did, and you know, if you stank or if this was amazing, what do you want to see next time, all that good stuff. Actually, I lied. You're gonna get all the feedback. So
yeah, please. I'd love to know how I can make this better if it wasn't helpful for everyone.
Oh no, this was fantastic.
Yeah, I think
it's a lot to cover.
Sorry. I think there were a few questions that our survey spam might have overwrote. So I do want to give those questions the time of day if appropriate there. I see Sean asked, what do you think about Kubernetes as a replacement for Vagrant for local development?
Oh, I love when this question comes up because so I'm a Linux developer, right? I have to use this MacBook for work, but Arch Linux is my go-to OS, right? I'm a big Linux fan, and so I don't like installing a bunch of dependencies on my system, right? Let's say you need a Redis database or a MySQL database locally. I will always do a Docker run Redis, map that port locally, so my app can talk to Redis instead of having to install Redis. So yeah, I use this as a replacement all the time. Docker Swarm, if you're not familiar with what Docker Swarm is, Docker Swarm voting demo. There's a really powerful, here we go. There's a great demo if you haven't looked at how containers work. So check this one out. I think it's Docker Stack, oh no, Docker Compose. So Docker Compose is a tool. Again, everything in this whole container world is all YAML. So I'm a YAML engineer, right? I said I'm a Go engineer, but I write more YAML than anything. And so you can actually specify what your environment looks like. So here you have some services, right? So this builds from the vote folder inside of your project. It'll run the Python, command app.py to start it. Here's those ports you're mapping. Networks are kind of just wires that you kind of plug into them, just kind of like I showed with services. They're just arbitrary, you can create them. Same thing with data volumes here. Right, but there's nothing better than to onboard onto a new team that's already containerized, and you git clone your master repo, whatever you're using, and you run Docker Compose up, and you have your full dev environment, right? You don't have to install any dependencies. So yeah, so these toolings exist. Docker Compose is awesome. Docker Compose actually works really well with Kubernetes as well. So it's not like if you use this, you can't use Kubernetes. They translate very easily between each other automatically. Besides load balancing and auto scaling, when would you want to deploy Fargate containers with Kubernetes and without Kubernetes? So Fargate you can either use with ECS or with EKS. ECS we didn't talk about very much, but it is if you don't actually if you have a container and all you care about is having your container run, you can create a ECS definition here. We call these clusters. You don't necessarily manage it as a cluster. It's kind of just like an isolation. But so I can create a cluster in here. That's not what I want. Cluster task definitions. They might have actually just changed this. Okay, here's what I'm looking for. And so inside of ECS, this is using Fargate. So this will kind of spin up magic backend. You don't actually have to worry about it. It's enough resources to run whatever you need. And it scales it, handles it all for you. So a lot of folks use ECS. It's great. It works really well, especially if you just have containers. Let me see if I can show you what a manifest looks like.
Yeah. Our particular example is going to be about 8 Fargates, where one's like a web server, and then the rest are APIs and maybe one database. Currently, everything's running on EC2s, and we want to move over to Fargate. So I'm just wondering, we don't need auto scaling or load balancing. So would we want to put Kubernetes in front of all that, or do something else like this ECS in front of the Fargates?
So it's something, I can't answer that question for you, unfortunately. I can give you advice. I believe ECS gets a little pricey because obviously it provides an additional service as in managing all that for you, right? So if managing a Kubernetes cluster is something you want to do, I think you can save money that way. But you might not want to. I work with Kubernetes, right? So I obviously try to avoid using it when I don't have to. So ECS is great for running an individual container or a group of containers. So it really comes down to like where you want to draw your line for ops management. They're both great. They're both absolutely great solutions. I think, okay, here's a better answer. If you want to use all of the tooling that is built for Kubernetes, then you'd obviously need to use Kubernetes, right? So if you want to use Cert Manager, if you'd want to use Ingress Controller, and there's a slew of other projects out there, right? If you'd want to use all those, then you obviously need Kubernetes. You can use Fargate with Kubernetes, but you'd still need to use Kubernetes.
Okay, thank you.
Yeah, hopefully that's the answer. Feel free to Slack me. What's next? What are some main reasons to deploy multiple node groups? So I skipped over this, but it was asked. So we can see EKS-CTL get cluster. So I will get my demo cluster, right? So I have my demo cluster here. And so the way EKS works is you create a cluster and then you create node groups under that cluster. And so here's my node group, right? And so the node group is tied to a specific EC2 type, right? So EC2 node type. And if you'd want to create different, let's say you want a big beefy one that you want to run your database on. You should never run your database in Kubernetes, right? Just don't do that, use a managed service. But if you had to, for some reason, you need like high IOPS or a high CPU, you can actually create another node group, or maybe you need GPUs, right? You can create GPU nodes. And then when you're actually creating those, it's in here somewhere, it's called like node affinity or node specification. You can declare this under deployment, and Kubernetes will only schedule your workload on a certain node type that matches a label or EC2 tag or whatever you want to come up with. But yeah, so that's the reason why you'd want to have multiple node groups, is maybe you need different, oh, here you go, this is what I was looking for, right? So this is an M5 large node group here. So maybe you just want different node types. So yeah, you can add affinities and select nodes. What else? Any thoughts on CDK? It's pretty cool. I have not played with it yet. If you're not familiar with CDK is, This is like the CDK, so the Cloud Development Kit, I believe it stands for. Yeah. So CDK is a way to basically like Terraform and CloudFormation, but you can write JavaScript, which is nice. And so, or Python, I think you can write. Yeah, TypeScript or Python. And so with the CDK in general, you can represent all your AWS resources, whether they're Lambda, EC2 nodes, whatever it is, you can define this with software. So maybe it might be better for you to create it that way, and you can kind of just run it, and it's basically the same as CloudFormation and Terraform. CDK8S is the same concept, but for Kubernetes. And I think it's pretty cool, actually. You can, you see here, this demo GIF is pretty cool. So he is creating a chart, which is kind of just a basic object in here, creating a new web service, right? So it's abstracted away some of those resources. And on the right side, you can see the YAML that gets spit out from this. So yeah, this is something you obviously can experiment with. I think for this to be effective, you kind of have to have buy-in from everyone to do it this way. But it's it's great to augment your creation. It's a great jumpstart too, especially when you don't, here you're working with a new web service as opposed to having to create a service and a deployment, right? So pretty much same defaults. I got another question. AWS SAM CLI for CDK. Do you see any advantages in using serverless as opposed to these ones? So I am not familiar with the SAM CLI. I actually just read about that this morning. I'm probably not the best person to answer that question, so I'm not going to butcher it. But I can get you an answer. I think that was the last question I had in here.
I believe that it was.
One quick note, OpenFast is a pretty cool tool if you haven't heard of this. So if it's pretty much open source Lambda that you could run on a Kubernetes cluster or other places. And so this lets you run functions on side of your cluster, right? So Kubernetes, I get in this argument with the guy who came up with Kubernetes.dev. It's not a containers versus serverless type thing. You can run serverless on top of Kubernetes. There's a bunch of different implementations. So don't think about this as containers or serverless. Think about this as, do I want to manage infrastructure? Do I need more control? Do I want to build an open source technology that's portable? These are all decisions that you have to make. Yeah, I literally saw an article this morning for SAM CLI, so I need to do some research there. It looked cool, so.
Only if you want to install Homebrew on your Linux boxes.
I was a fan of Linux Brew for a little bit, but then things got spicy.
Spicy, nice. All right, well, that brings us to the top of the hour. And Mr. Planky, how many respondents have we had to my irritating call for doing the survey?
23, which might be a record high. So I don't know if it's how annoying you were with it or if it was the shaved face, but we're getting surveys, Chris. So very exciting day.
I actually flipped over to Twitter and started DMing people on the back end saying, do the survey.
Which screen are you guys seeing now?
The click to spin.
Awesome. Okay, so I am not going to share everyone's emails this week if I do my job correctly, but I am up to 24 responses. So we are going to do 3 raffles of $25 AWS gift cards. Eddie, I'm not sure how many clusters that will allow you to spin up before you start getting charged, but hopefully it's a few. If it's not, well, that's like most AWS services that we demo here. So I'm going to go ahead and give this a spin.
I like the quote from Mr. Rogers.
I didn't notice that. All right, winner 19. If you had my headphones in, you would hear cheers and clapping. You don't. I suspect you can't hear it, but number 19, that is going to go to, all I have are emails here. So if doust.andrew If that sounds familiar to you or slightly butchered, you'll be getting an email shortly from AWS Pug with a $25 gift card.
Yay, Andrew. Good job. Good job winning the RNG today.
More clapping, more cheering. I'm very excited for number 17, Gifted. Gifted Lane, if that means anything to you, you will be receiving a $25 AWS credit.
Nice. Good deal. That's one of the people I irritated on Twitter. Paid off.
All right, lower number here. Number 4, C Bossy. You will be receiving an email from us as well.
That's Craig Bossy. Nice.
Awesome. Did I say I was doing 3 or 4?
You said 3.
You said 4.
I said, yeah, all right.
You said 4.
Let's go 4. Let's just do one more.
Absolutely.
Got a good turnout. We're feeling generous today.
Go for broke. Making it rain. Compute credits.
Number 18. All right. Sean, this one is you. You are a repeat winner almost every week. So congratulations. You will be getting another email from us.
See, that's what happens when people show up often. We're all winners here, just some more than others.
Now, what are the odds of 3 consecutive numbers being winners, 17, 18, 19?
I noticed that. I don't know the odds, but that was definitely strange. Maybe we don't trust this tool. I want a Kubernetes version of this by the next meetup, if someone can spin that up. I want some of these to be public and things like that, but we'll see about finding a more random number generator going forward.
If I can say it's kind of interesting. I run the Boston version of this meetup, and we do our raffles we ask questions about Battlestar Galactica, and whoever answers them first in the chat wins.
Yeah, but then you're getting rid of all the people that don't have any Battlestar Galactica knowledge.
Your point?
Wow, self-selecting.
Yeah. Well,
that's why none of us go to the Boston meetup. Over here in Portsmouth, we keep things a little more friendly. Diversity and inclusion is big on our list here.
Well, we do sometimes ask about Firefly, so it's.
I'm gonna start attending the Boston meetup just to be a ringer plant for the non-Serenity actually I watch both of those. I watch BG and Serenity, so I never mind. Yep. I'm living the stereotype. Great, cool. Eddie, thank you so much for coming out and joining us tonight. This was awesome.
Yeah, thanks for having me. It's I know this is a lot, right? So again, Kubernetes is like a scary thing. It doesn't hurt to play with, especially if you won that credit, right? Like that's spin it up, spin it down. When you're creating manifest, it's all deployable and repeatable, which is pretty great. Also, if you have Raspberry Pis, there's a K3S. It's 5 less than Kubernetes. So you can deploy K3S on your Raspberry Pis. I actually have a 3-Pi cluster over there. And it's basically just a full Kubernetes cluster for super fun and cheap in your network closet or your office.
So because of some of the VMware crossover with VMC and everything, I saw that they stood up something called Kube Academy, kube.academy. Is that a good 101 place for people to cut their teeth on Kubernetes?
Thank you for reminding me. The EKS workshop is actually what I'm not familiar with Kube Academy. It could be great. If you go to eksworkshop.com, this is an awesome resource to get started. It takes you, I completely forgot this. Thank you for reminding me. EKS Workshop. There's also ECS Workshop if you want to mess around with ECS as well. We didn't talk about it much, but yeah, these resources are great. They're completely open source too, so feel free to feel free to poke around, submit any bugs, and there's tons of content in here. So
cool, awesome. I'll be posting all of the links for all of this in the YouTube channel when we post it online. So nobody has to write these URLs down furiously now. I'll do that later.
just need to share. So I guess Craig Bossy is AWS, and so he wanted to donate his spin. So
Oh, nice.
very exciting. We have another spin coming around here.
If it's Brian, he's not going to get it because.
All right, Richard's one mon. You are the final winner of those. So thank you, Craig, for giving up your spin there. Appreciated.
What was that email address again?
Richard's one mon.
Oh, okay. So, okay, we've got a couple. I thought it was Richard, the other AWS employee that's also in here, but no, that doesn't sound to be the case. Cool. All right. Well, congratulations to everybody that won and everybody that learned about EKS. So everybody won tonight. This is fantastic news. Eddie, thanks once again, man. Great having you out.
Yeah, thanks for having me. I'm always happy to come, and maybe I'll get to come in person one day. So I'd love to do that.
You know, when we can all hang out together and have a nice frosty beverage, and that'll be absolutely wonderful. Cool. All right, everybody, have a wonderful evening. I'll post Eddie's Twitter information once again in the YouTube channel, and feel free to hit him up. He's one of the dev advocates for AWS, so he loves answering all of our questions. All right, thanks everybody. Have a great night.
Thanks everyone.
Yeah, thanks.